Hello everyone. Here we enter the exercise 6 about parabola. So, I hope you know now that any equation with an exponent 2 with a square on the x creates an hyperbola, and you saw it on what I sent you that it has a shape of a U, up for positive A and down for negative A. Alright, so that's the basic. Then yesterday you learned what is the turning point. So that's exactly the point where it stops decreasing, start increasing, or when it goes that way, that's the maximum point here. Alright, so turning point was yesterday's lesson, and you know it has four coordinates P and Q from the equation of the parabola. You can as well find the x value of the turning point with the formula minus b over 2a if your equation was written as ax squared plus bx plus c. Alright, so that was yesterday's work. You did the homework and I corrected, so that should be already known now. Alright, for today we have the third part, the x-intercept. The x-intercepts are as well called sometimes the 0 points or the roots. And in a parabola, because you have a second degree equation with an exponent 2, you have two roots, the positive side and the negative side. Sometimes those two roots can be equal, which gives you only one solution, and sometimes the graph never crosses the x-axis, therefore there is no x-intercept. So you have three options. So you should remember that when you want the x-intercepts or the roots, you need to solve for y equals 0. We saw that already with straight lines. So for x-intercept, you make y equals 0 and you solve. And you have the three cases. So remember, for a parabola, we're talking about a trinomial equation. And we have three ways of solving the trinomial. Or we factorize it with two brackets, or we use the perfect square method. If we use the perfect square method, we have that equation as a perfect square equal a number, and we square roots both sides to find the two solutions, the plus and the minus square roots of that. And the third one is the delta formula. So this one you remember. The delta formula is the b squared minus 4ac, and there is three options. Or the delta is positive, you've got two solutions, which is this case. If the delta is positive, the graph crosses the x-axis twice, so you have the x plus and the x minus. If the delta is negative, it means that the graph is never going to cross the x-axis, so there is no real solutions. And if the delta is 0, exactly 0, then the two roots are equal. You have only one intersection, only one solution. Alright, so when you want to solve the equation equals to 0, you can use the delta formula. Find the x plus and x minus. Check what is the value of delta. Alright, I gave you example 1. So here we add 2x squared minus 3x minus 2, and we want to find the roots or the x-intercept. So we solve. This equation equals 0. We have a is 2, b is minus 3, and c is minus 2. Apply the delta formula, b squared minus 4ac. If I apply it correctly with brackets, no sign mistakes, I'm getting 25. 25 is a positive delta. That means I'm going to have two solutions. The graph is crossing the x-axis twice. Alright, then now I'm looking for the two solutions, the positive and the negative one. So that's minus b plus or minus square root delta over 2a. Substitute properly, no sign mistake, and then I open my two solution, the positive one with the plus square root delta give me 2, and the negative one with the minus square root delta gives me minus a half. Alright, so if I draw this equation, that one, 2x squared minus 3x minus 2, I'm getting this graph. And as you can see, the positive root on the right hand side is a 2 for x and obviously a 0 for y. And the negative root, or the negative x-intercept, is a minus a half for x and a 0 for y. So I'm verifying graphically when my delta is positive 2 roots, and for this specific equation I'm getting those 2 x-intercepts. Alright, I gave you a second option, second example. Here we add y equals 2x squared plus 3x plus 2. So you need to do the same thing. You want the x-intercept, so you solve for y equals 0. A is 2, B is 3, C is 2. Delta formula, you get minus 7. Negative delta, your graph is going to be above the x-axis. It's never going to cross it. Therefore, no real solution. You don't have x-intercepts. It's not going to cross. Alright? Right. Then, you have to know as well how to find the y-intercept. So this one is the same than with the straight line basic. When you want the y-intercept, you make x 0 in the formula. So for instance, if y equals 2x squared plus 3x plus 2, you just substitute x with 0, and you get 0 plus 0 plus 2, y equals 2. So the y-intercept is 0 for x, 2 for y. If you check on the graph, 0 for x, 2 for y, that is your y-intercept. Alright, and the last thing, that's the axis of symmetry. So a parabola has a U shape, facing up or facing down, doesn't change the fact that there is an axis of symmetry going right in the middle of your graph. And this specific point, this specific axis of symmetry, is going through the turning point. If you fold your paper on that axis here, the two halves are going to be overlapping perfectly. So this blue line is the axis of symmetry, and it goes exactly on the turning point of your parabola. So if you understood properly the previous lesson, the turning point as for x value, when the equation is given as ax squared plus bx plus c, the x value of the turning point is minus b over 2a. So you would get the axis of symmetry as x equal the value of the turning point for x here. In case the equation is given as a bracket x minus p squared plus q, the x value of the turning point is the p value. So that's straight, you just read in the equation. So the p value is the x of your turning point. So this vertical line as for equation x equals p. Alright, so let's check. For instance, find the axis of symmetry of this equation, 2x squared minus 3x minus 2, which is the one here. So in this case, I've got the form as ax squared plus bx plus c, so I'm going to use the x value of the turning point that has for formula minus b over 2a. Okay, so minus b is minus 3 over 2a over 2 times 2. That gives me that those two minus gives me a positive 3, and the 2 times 2, 4. So the x value of the turning point is 4 over 3, 3 over 4. So that's the equation of my vertical line. X equals 3 over 4. That's the axis of symmetry on the x value of the turning point. Alright, so now your turn. You've got the whole weekend to do it. Please don't forget, Monday morning I want those 2 questions done. You have 3 days to do it, so please don't wait for the last second to send me the work. Okay, this one written as the first form with the perfect square. So check if you can find all the value for this line. And that one written as a trinomial ax squared plus bx plus c. The same. Check if you can find all different values for this graph. Okay, if you didn't notice, those 2 are exactly the same than the 2 you had to draw for today. So you can use this graph to check your answers. But you must calculate everything for this homework. Alright, good luck, enjoy!